Meshing is a critical part of the finite element analysis process. In Autodesk Simulation Mechanical, automatically generated meshes can be based on CAD solid or surface geometry from many sources, as well as on 2D outline sketches. Structured or hand-built meshes are covered in a separate video. The hub and bearing housing assembly pictured here is an example of a mesh based on a CAD solid model. The overwhelming majority of the surface area is covered with quadrilateral element faces. In the same manner, the solid mesh engine attempts to fill the majority of the volume with 8-node brick elements, also called hexahedra. The default solid mesh is a hybrid of hexahedral, wedge, pyramid, and tetrahedral elements, with those of the highest quality placed near the surface where stresses are critical. Lower quality elements are used when necessary to fill the innermost volume of the parts. You can control the mesh size globally, on a per-part basis, or locally by applying mesh refinement to selected vertices, edges, or surfaces. This image shows the local mesh size reduction resulting from refinement points added to the original surface mesh. Global and local mesh refinement utilities are also provided to automate the process of mesh convergence, that is, the progressive refinement of a mesh until stable analysis results are obtained. For example, this image shows the change in the maximum principal stress result of a notch test specimen as the global mesh size is decreased. Similarly, this image shows the maximum principal stress convergence of another notch test specimen as the local mesh size is decreased. Plate or shell type elements can be generated from CAD surface models, as this example illustrates. For solid models of thin parts, which would best be analyzed using planar elements, the mid-plane meshing option is available. This option collapses the CAD solid model to surfaces at the mid-plane of the part thickness, as this example demonstrates. You can perform 2D mesh generation on outline sketches created on a plane of any orientation. The resultant 2D meshes can be used for any planar elements or extruded into solid elements. To run a 2D element analysis, the mesh must be generated on the global YZ plane. The sketch can be drawn within Simulation Mechanical or imported from an AutoCAD DXF file. The outline can also contain multiple parts. Here we see an outline of a mandrel shaft cross-section. Here it is after 2D meshing. And here it is extruded into a 2-foot-long solid element mesh. This was made by copying the lines comprising the 2D mesh using the join option to produce the lines in the direction of extrusion. This type of a model uses a hybrid of automatic and structured meshing techniques.